Hello everyone, this is MJS Pawan. In the previous video, we have discussed the first order linear differential equation and also finding the integrating factor. Along with it, we have learned the plotting of a graph for a general function. In this video, will learn about the homogeneous linear equation and some special cases. If you haven't watched the previous video, please do watch. The links are given in the description box. So if you haven't subscribed to my channel, please do subscribe to my channel. Let's begin the section. Homogeneous linear equation. So a homogeneous linear equation is the one which all terms contain exactly one power. Means here the power is one, of which that is the dependent variable. In the previous video also I mentioned that what is the linear equation. So you can check there once again. The equation example d square y by dx square plus y dy by dx plus 6y is equal to 0. For this equation, we add up the solution. So if f of x is the solution and g of x is the solution, so you can write this as replacing y by f and g by x, you will get the two equation of the same kind. Then, so if a into f of x plus bx for a given constant a and b, these are the constant terms. So we can write as this y term as this term as y, and so that will be a f of x plus b g of x plus phi d by dx a f of x plus b g of x plus f6 a f of x plus b g of x is equal to 0. That is the equation which I have considered for an example. So we will be substituting this y value in this expression, so we will be end up with this expression. An nth order homogeneous linear equation will always have a exactly n independent solution. Means the solution for an nth order case will be having an n independent solution. Will be having that will be y1, y2 up to yn, and the general solution we can write it as y is equal to c1 y1 plus c2 y2 plus so on up to cn yn. So for better understanding, let's consider an example. Before that, I'll discuss a special case. Suppose we are given a differential equation of an rth derivative is a constant multiple of xr. So let's consider an example is x square d square y by dx square plus 2x dy by dx minus 6y is equal to 0. How we can solve this is, here the power contains x power r term is based. So how we can solve this expression? Then we try to form a solution of this form. Y is equal to x power m. In the place of r, I have written m. So now just differentiate this with respect to x one time. So we will be getting dy by dx m into x m minus 1. Again differentiate d square y by dx square is equal to m into m minus 1 x into m minus 2. So now what you are going to do is substitute this value and this value in the equation 1. So we will be end up with x square m, that is this term d square y by dx term, and 2m x power m minus 1 minus 6 into x power m, because here y is equal to x power m I have taken. So now take out the x power m common out, so we will be end up with m into m minus 1 plus 2m minus 6 is equal to 0. Again solving this inner term, will be end up with m square plus m minus 6 into x power m. Shift this x power m this time, so we will be getting m square plus m minus 6. So you know that you can solve this equation, quadratic equation, m minus 2 m plus 3. The roots will become here is m is equal to 2 and m is equal to minus 3. That is m minus 2 is equal to 0, one term, then m is equal to 2. Similarly, m plus 3 is equal to 0, m is equal to minus 3. These are the two roots. This means we have found the two functions that work as a function to our differential equation. That then the function will become solution of that function will become y1 is equal to x power m, because I have taken y is equal to x power m. So here m1. So m1, what is the m1 is? m1 is equal to 2. So x square. So y2 becomes m into x power m2, that is equal to x power minus m3, because m2 value is minus 3, second root. But we know that if we have two solution, we can use any combination of them in our general solution. Means we can write first this term, later this term, or first this term, or next this term, like alternative manner. So the order doesn't matter. So you can write y is equal to c1 x square plus c2 x square. This is the solution of the equation. This one more thing you have to remember is this work for nth order derivative, but there will be having m and n different real roots. Okay, let's consider an example. Y is equal to x power m. Similarly, I have considered in the previous slide. Dy by dx is equal to m into x power minus m. D square y by dx square is equal to m into m minus 1. Differentiate again. This term goes here again for the second order. So m minus 1 x power m minus 2. So now substitute these two values in this expression. So you will be getting this equation. Now take x power m common, m square minus m minus 6m plus 6 plus 10 is equal to 0. Now the roots becomes m is equal to 5 and m is equal to 2. So the general solution of this equation is c1 x power 5 plus c2 x square. Some special cases with a constant coefficient. Now suppose we have an homogeneous with a constant coefficient like this one. If you haven't know what is the constant coefficient, go back to the video one. We'll get the what does it mean. Now we try with y is equal to e power lambda x. In the previous video, y is equal to x power m we have considered. Then when you do the differentiation of this one, y dash is equal to lambda into e power lambda x. When you do the second time differentiation, lambda square into e power lambda x. Now substitute this value, you will be getting this equation. So lambda square plus 5 lambda plus 6 e power lambda x is equal to 0. This is for all x. Now finding the roots, we will be getting lambda is equal to minus 2 and lambda is equal to minus 3. So this is the general solution of the equation y is equal to c1 e power minus 2x plus c2 e power minus 3x. Suppose if there is a third order differential equation, similar there here also we have to do y dash is equal to lambda into e power lambda x, y double dash is equal to lambda square e power lambda x, y triple dash is equal to lambda cube e power lambda x. So now put these values in this value in this equation. You will be getting lambda cube e power lambda x, lambda cube into e power lambda x minus lambda square e power minus lambda x minus 2 lambda into e power lambda x. Take out lambda common and e power lambda x common. So you'll be getting lambda square minus lambda minus 2 is equal to 0. Now transfer these terms to this side and you will be having the e power lambda will be going that side. So lambda times lambda square minus lambda minus 2 is equal to 0. So roots will be lambda is equal to 0, and when you solve this expression, lambda square 2 lambda plus lambda minus 2 is equal to 0. Lambda square, take lambda common, lambda minus 2 plus here 1 common, lambda minus 2 is equal to 0. So roots are lambda is equal to 2, lambda is equal to minus 1. In case of repeated roots, suppose if the roots are repeated, so what we have to do is again take y is equal to e power lambda x. Now differentiate y dash is equal to lambda into e power lambda x, y double dash is equal to lambda square e power lambda x, y triple dash is equal to lambda cube e power lambda x. So we will be getting lambda cube e power lambda x minus 2 lambda square e power lambda x plus lambda into e power lambda x is equal to 0. Take lambda and e power lambda x common. So lambda square minus 2 lambda plus 1 is equal to 0. Here same as the previous one, lambda square minus 2 lambda plus 1 is equal to 0. Lambda square minus lambda plus 1, lambda is equal to 0. So roots will become lambda is equal to 0, one root, one more will be lambda into lambda minus 1 minus lambda minus 1. Lambda is equal to 0, that is first root. Lambda 1 is equal to lambda 2 is equal to 1. So in this case, the general solution will be c1 into e power 0 plus c2 into e power 1 x plus c3 into x into e power x. This is 1x. So you can see here, since the roots are same, means roots are repeated, we will be having the expression like this form. So alternately you can write this as an y is equal to c1 plus c2 plus c3 x into e power x. This is the general solution of this differential equation. Thank you for watching. If you have any doubt, please comment on the comment section. Please don't forget to subscribe to my channel. Thank you.